13.1, 23. Find limit x tends to 0 f of x and limit x tends to 1 f of x, where f of x is defined like this. So this is the function given, f of x. 2x plus 3 when x is less than or equal to 0 and 3 into x plus 1 when x is greater than 0. That is the function given. We have to find limit x tends to 0 f of x and limit x tends to 1 f of x. So first we will find limit x tends to 0. Limit x tends to 0 f of x. So to find limit x tends to 0 f of x, we have to find left limit and right limit. So limit of the function is said to be some number if left limit and right limit both are equal and exist. So we will find the left limit and right limit. So first we will find left limit, that is limit x tends to 0 minus f of x. So left limit means limit x tends to 0 minus f of x. After 0 put minus. So x tends to 0 minus f of x means what is the limit of the function f of x as x tends to 0 from left. That means here x tends to 0 from left means x is less than 0 but coming very close to 0. X is less than 0. So that is equal to limit x tends to 0 minus. So we have to write the function f of x when x is less than 0. In the left limit, when we find the left limit, that means x is less than 0 and x is coming very close to 0. So when x is less than 0, what is the function? When x is less than 0, f of x equal to 2x plus 3. So we can write the function f of x. In the place of f of x, we should write f of x when x is less than 0. So that is the function 2x plus 3. Now we can apply the limit. X tends to. So this 0 minus means that it is left limit. But x tends to 0. We have to find the limit of the function as x tends to 0. Now we can apply the limit as x tends to 0. In the place of x, now we use the usual method of evaluating the limit. That means in the place of x, we will substitute x equal to 0. X equal to 0, we substitute in the place of x. So we get 2 into, that is 2 into 0. 2 into 0 plus 3, that is equal to 0 plus 3, that is equal to 3. So we got left limit of f of x as x tends to 0 equal to 3. Now we can find the right hand limit, that is limit x tends to 0 plus, after 0 put plus. So limit x tends to 0 plus, that means it is right limit of f of x. So that is equal to limit x tends to 0 plus, limit x tends to 0 plus. Now write f of x when x is greater than 0. Right limit means x is greater than 0 and very close to 0. So x is greater than 0, what is f of x? From the given function you have to write. So f of x when x is greater than 0. X is greater than 0, f of x is 3 into x plus 1. So write 3 into x plus 1. Now we have to evaluate the limit. So in the evaluation of limit, we substitute x equal to 0. In the place of x, we have to put 0. So that is equal to 3 into 0 plus 1. That is equal to 3. So we got left hand limit equal to 3, right hand limit equal to 3. Both are equal. So we can write the limit of the function. Therefore, limit x tends to 0, f of x is equal to 3. Since left hand limit equal to right hand limit, both are equal to 3, we can write the limit of the function f of x as x tends to 0 is equal to 3. So only if the left hand limit and right hand limit exist and are equal, then only we can say that limit of the function as x tends to 0 is equal to 3. So that we got the answer, limit x tends to 0 f of x. Now we will find limit x tends to 1 f of x. Now when we find limit x tends to 1 f of x, we want to find limit x tends to 1 f of x. See, when we find the limit, first we have to think whether we need to find left hand limit and right hand limit. Left hand limit, when we find limit x tends to 1 f of x, limit x tends to 1 minus f of x. This is called left hand limit. Limit x tends to 1 plus f of x. This is the right hand limit. So when we find the limit of function f of x as x tends to 1, this is left hand limit, this is right hand limit. So left hand limit means x less than 1, Here x is greater than 1. In the right hand limit, x is greater than 1 and very close to 1. X tends to 1 minus. In the left hand limit, x is less than 1 and very close to 1. So in that case, one thing you have to find out, think. That means whether we need to find left hand limit and right hand limit. This and this we need to find or not. See, where only this means x less than 1. This means x greater than 1. So if when x less than 1 and x greater than 1, if f of x is different, then only we need to find left hand limit and right hand limit. See the definition of function, given function, see the definition. Using that we have to think whether we need to find left and right limit we need to find. So here when we find x tends to 1, that means x less than 1, x greater than 1. But remember one thing, x tends to 1 and it is very close to 1. So when x is very close to 1 and x less than 1, see here, see x greater than 0, the function is 3 into x plus 1. And x less than 0, this one. So x greater than 0, for all values of x greater than 0, the function is 3 into x plus 1. Here we need x less than 1 but very close to 1. For example, x less than 1 very close to 1 means 0.99. So when x is, in this case, suppose, one example I am telling, when x is 0.9, very close to 1, it is close to 1 and less than 1. Now here in this case x greater than 1. So and very close to 1, take x 1.1. So when x is 0.9, what is f of x? X 0.9 means it is greater than 0. So f of x is 3 into x plus 1. When x is 1.1, in that case also x is greater than 0 and same value 3 into x plus 1. So in both cases x is less than 1 and very near to 1. X is very close to 1. Or if x is greater than 1 and x is very close to 1. In both cases this f of x is same 3 into x plus 1. So we don't want to find the left hand limit and right limit. Only direct one limit only we need to find. So directly we can find limit x tends to 1 f of x equal to no need of left and right limits. Because both the cases f of x is same 3 into x plus 1. So directly we will find limit x tends to 1 f of x equal to limit x tends to 1 f of x. What is f of x? When x tends to 1 means x is coming very close to 1 from left or right. Whatever it is, f of x is same. X is very near to 1. That means x is greater than 0. So f of x is 3 into x plus 1. 3 into x plus 1. So now we can find the limit. That is equal to when limit x tends to 1 f of x. What is the method of evaluation of limit? We substitute. So put x equal to 1. So we get 3 into 1 plus 1. That is equal to 3 into 2, 6. So limit x tends to 1 f of x equal to limit x tends to 1 f of x equal to 6. So we found both the limits. Limit x tends to 0 f of x and limit x tends to 1 f of x. So in this case we found both left and right limits because x less than 0. X less than 0 function is this one. X greater than 0 function is different. So we found both left and right limits. But in this case x less than 1 or x greater than 1 and x is very close to 1, function is same 3 into x plus 1. So no need to find left and right limit, directly only one limit we need to find. So we got the answer 6. Now next question, limit x tends to 1 f of x when f of x equal to this, x less than or equal to 1, x greater than 1, function is this one. So we were here in this question, what we want to find? We want to find limit x tends to 1 f of x. So when we want to find a limit, we have to see the definition of the function, how the function is defined. When x is less than or equal to 1, f of x is this one. When x is greater than 1, function is this one. So when x is less than 1, function is this. We want to find limit x tends to 1. So when we find, so whether we need limit x tends to 1 minus f of x. This is left limit. Limit x tends to 1 plus f of x. So this is the left hand limit at x tends to 1, at x equal to 1. This is the right hand limit at x equal to 1. So here this means x less than 1 and very close to 1. In this case x greater than 1 and very close to 1. So when x less than 1, f of x is this one. X greater than 1, f of x is this one. So we need to find both left limit and right limit. So we'll find first left limit. Limit x tends to 1 minus. Now think what is f of x when x is less than 1. x tends to 1 minus, in the left limit, x is less than 1. When x is less than 1, what is f of x? See, x is less than 1, f of x is x square minus 1. Now, after writing the function, we can apply the limit. This minus means only that x is less than 1 and x is coming very close to 1. And don't substitute x equal to minus 1. After 1, we are putting minus. X tends to 1 minus. So, now directly we can apply, put x equal to 1 in the place of that evaluation of method, evaluation of limit. So, in the place of x, we have to substitute 1. So, 1 square minus 1. So, that is equal to 1 square minus 1, that is equal to 0. Now, we can find the right limit. That is equal to limit x tends to 1 plus. What is f of x? When before writing f of x, think what is f of x? When x is greater than 1. Right hand limit means x is greater than 1. So, when x is greater than 1, what is f of x? X is greater than 1, f of x is minus x square minus 1. So, minus x square minus 1. Now, we can apply the limit. When we apply the limit, we can substitute x equal to 1. So, in the place of x, we directly substitute 1. So, we get minus 1 square, that is minus 1, minus 1. So, we are in the place of x, we have to substitute 1. So, minus 1 square 1, not minus 1 whole square, minus, after minus, we have to find 1 square. So, minus 1, that is minus 2. So, left hand limit at x equal to 1 is 0, right hand limit minus 2. So, left hand limit not equal to right hand limit, therefore, limit does not exist. So, we can write limit x tends to 1 minus f of x is not equal to limit x tends to 1 plus f of x. So, left hand limit is not equal to right hand limit, therefore, limit x tends to 1 f of x does not exist. So, we have to write limit x tends to 1 f of x does not exist because left limit is not equal to right limit. Now, see the next question, limit x tends to 0 f of x, limit x tends to 0 f of x where f of x equal to this function. Here, it is defined as modulus x by x when x is not equal to 0 and equal to 0 when x is equal to 0. Here, modulus x always we have to change. We know the definition of modulus x. What is modulus x? How modulus x defined? Modulus x equal to x when x greater than or equal to 0 and equal to minus x when x less than 0. That is the definition of modulus x. But here, when x is equal to 0, it is defined as 0. So, we have to x not equal to 0 means it can be x less than 0 or x greater than 0. So, we can consider when x greater than 0. So, we can substitute that value of modulus x in the function and we can rewrite the function and we can find the limit. So, in the next session we can find.